All right, our next set of notes, our next topic of learning is 3D figures that are formed by two-dimensional rotations. So a solid of revolution is a 3D figure that is obtained by rotating a 2D figure or a curve. And so we're going to talk more about figures because this is Math 3, but when you get into higher levels of mathematics like calculus, then you'd start to look at curves around a straight line. And this straight line is called the axis of rotation. That lies in the same plane. All right. So the most basic example that I could think of is something that most of us have seen. This picture is really hard to see because I printed this in black and white. But if you look at this, we have revolving doors. I'm picturing, like if you guys have ever been to the airport, typically they have revolving doors at the airport. Sometimes you've seen them maybe at special malls. I'm trying to think of any malls that I've been to in North Carolina that have had revolving doors, but not really. Um, but this is like sketch of a revolving door, and you can see, so the 2D part of it is that you have like a rectangle, right? That's the two-dimensional part. And if you take that two-dimensional door and you rotate it around this straight line here, so the straight line is the door frame or the main pane that it's kind of rotating around, whatever the door is connected to, the panel, whatever, I don't know what that's called. When you rotate it around, you can see that it's making a cylinder shape. So what solid is formed from a revolving door? It's a cylinder, right? Example 2. If we take a triangle, what solid is formed when rotating a right triangle? So if you take this, you spin it around, here's the vertical line, that's the axis of rotation, you're going to get a cone. If you want to get the volume of that solid, you just have to look and figure out what the area of the base is. So we can see this base right here of the triangle that had a base of 3. That base of 3 becomes the radius of the cone. So we're going to say the radius of the cone equals 3. The height of the triangle becomes the height of the cone. So I'm going to go ahead and label it right here in the cone. We have a radius of 3. We have a height of 4. So the area of the base is pi times 3 squared. So that's 9 pi. The volume of the cone is going to be 1/3 times the area of the base times the height. So if I'm going to find the volume of the cone, I'm going to do 1/3 times 9 times 4. 12 pi units cubed is the volume of the cone. Okay. What is the solid formed when rotating the shape below? So here we have a bigger circle or half circle here and then a smaller half circle. And you can see that when you rotate it around, it makes a sphere, but it's a sphere that would be hollow. So this is going to be a sphere with a hollow center. Okay? So we're going to find the volume of the outer sphere, and we're going to find the volume of the inner sphere. We're going to go ahead and subtract them, and that's how we're going to find the volume of the shape. So the volume of the outer sphere, you can see they gave you the radius of the outer sphere. That's a radius of 5. So we're going to say 4/3 pi times 5 cubed. 4/3 times 5 to the third. And then the inner sphere has a radius of 3. 4/3 times 3 to the third. So if we want to find the volume of the hollow sphere, the sphere that is empty in the center, we're going to do the outer minus the inner. You'll notice that I'm subtracting just the numbers that are in front of the pi, the coefficients, and I'm sticking pi on the end of the answer. So I have 130.667 pi units cubed. That is the volume of the hollow sphere. Okay. Next, you have a circle that is a space, a little bit of a space away from a line, and they are taking that and they are rotating it around the line. And if you can kind of picture what would happen, this would give you a donut shape. I wrote shap. Donut shape. Okay. It's a donut shape. So again, there's that space in the middle. So just like this previous problem, see how we had space in the middle? So when we rotated it around, there was space in the middle. It made it hollow. Same thing here. When you rotate it around, there's space in the middle. It ends up making it hollow. All right. When we looked at this example, there wasn't space in the middle. It was right up against that axis of rotation that made it so it was solid. When we formed the cone, it wasn't hollow in the middle, it was solid. Okay. With this one, when we took the revolving door, it's right up against that axis of rotation. That's a solid cylinder, right? So when you take whatever your two-dimensional object is and you rotate it around, you're going to pay attention. Is it right flush against that line that's the axis of rotation? Or is there some space? If there's some space, you're going to have something hollow. If there's not space, then you're not going to have anything hollow. Okay? All right. Let's go ahead and look at the next problem. So this one, we have a shape, a two-dimensional shape that's on a coordinate plane. And they have it on a coordinate plane because it's going to help us be able to find some numbers so that we can find the dimensions and find the volume. So here we have a rectangle. The rectangle is being, again, rotated around the axis of rotation. And then here they're asking us what solid is formed. Again, it's a cylinder. Okay. And if we look, we can see that the radius of the cylinder is 3. And the height of the cylinder, 1, 2, 3, 4, the height of the cylinder is 4. And you can see it in the picture here too. The radius is going to be 3, the height is going to be 4. So you can see it in both pictures, what that information is going to be. So what's the volume of the solid? So we're going to say the area of the base is going to be pi times r squared. That's 9 pi. The volume of the cylinder is going to be the area of the base multiplied by the height. So 9 pi multiplied by 4 is 36 pi units cubed. Okay. So let's think about some volumes. Let's think about some solids that we noticed. Solids that were formed in rotations. We saw cylinders. we saw cones, we saw spheres, okay? What do all of these have in common? They all have circles. All right, because when you talk about rotations, you are having either in these two, we're going to have the base shape as a circle, or in the case of a sphere, you're talking about a 3D circle. So all of these, when you're taking something and rotating it around, a circle is being formed. Okay, so solids not formed by rotations. Solids that you will never see formed by rotations, ever, 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 are prisms and pyramids. That's because these don't have circles in them, so you can't get them from rotations, okay? We will never see these. So when we start working with rotations, when we're doing these assignments, we're going to see lots of cylinders, cones, spheres, all sorts of variations of that. So we saw, this is kind of a variation of a cylinder, right? It's kind of hollow in the middle. It's got something funky going on, but it's kind of a variation of that. You know, this is a variation of a sphere. It's hollow. This is a cone. We've got a cylinder. We can have things that have something weird going on, but it's going to be a variation of one of those shapes because it has to have a pi r squared somewhere involved in the problem. It's got to have a circle somewhere in the problem if it happened from a rotation, okay? One last thing I want you to do to your notes. I want you to label this and this as the axis of rotation, so you know what that is. All right, axis of rotation. And now you're done.